As humans, we have evolved to digest really well. And the reasons for that is that we want to extract as much nutritional benefit from the foods that we take in, but also that we want to protect ourselves from bacterial infection or fungal infection or other types of infections. The real issue becomes important when we want to develop a drug that we can actually consume orally, because you want the drug to sustain and resist digestion. You don't want to get it broken down. You want it to perform before it gets broken down, and that's what we call bioavailability.
Oral bioavailability is the description of what happens to the active pharmaceutical ingredient in a capsule or tablet, and as to whether it makes it from the dosage form in your gut across into the blood intact. This question is one of the holy grails of the pharmaceutical industry. They've been trying to do this for decades, but the idea that you could convert biologics, including peptides, proteins and antibodies, into oral dosage form would be a real game changer for both the industry and for patients. So for the industry, it would probably reduce costs because they wouldn't have to invest in sterile production of parenteral dosage forms. It would be much cheaper to create oral dosage forms. For patients then, it'd be much more convenient for them to take tablets or capsules at home. They wouldn't need to go into hospitals for infusions. This means they take their medicines more readily, compliance would improve, and definitely outcomes for treatment of disease would improve no end.
So at Nuritas, we have a unique capability in that we have an artificial intelligence technology that can actually identify drugs really, really well. The two questions we asked at the very beginning of this project were, first, can we make these drugs orally available? And secondly, can we also create another artificial brain that can very quickly, at the very beginning, at the prediction level, when we're actually creating the drug and discovering the drug, can we see if we can find whether that drug is bioavailable? So the project here will allow us to do both. One is on the pipeline of drugs that we're developing, can we make them more orally available? And secondly, can we, at the very beginning, create a drug from day one that is highly functional, but also has a very high bioavailability. And the goal of all this is really to reduce injections, so making drugs more orally available.
This Beacon project will focus on two important aspects. Firstly, we mimic the gastrointestinal digestion in vitro to see which peptides survive this physiological process. We test the intestinal absorption of the compounds by developing an intestinal barrier using human intestinal cells. Once the barrier is created, we apply the gastrointestinal digested compounds to see which peptides are able to be transported. After this, we can formulate or modify the peptides to increase their oral bioavailability if required. We do this using state-of-the-art in vitro and ex vivo techniques, such as using chambers, in collaboration with world-leading expert Professor David Braden.
The aim of this two-year collaboration in this project with Nuritas, UCD and the Science Foundation Ireland Beacon Centre is to create oral dosage forms of the proprietary peptides that have been derived from food by Nuritas bioinformatics scientists. So the idea is to select a group of peptides and put them into dosage forms and see whether they actually make it intact into the blood, and then to create practical formulations around that.
So Beacon is a Science Foundation Ireland funded Bioeconomy Research Centre. I think the Nuritas project is a perfect example of where we're using very advanced technology to address a very complex and challenging problem. So for us, it's a perfect match. We believe that the bioeconomy is about using smart technologies, using our knowledge and applying that to our natural resources to generate products of value. So if we combine that expertise and that leadership from Nuritas and from Professor Braden, then what you're going to deliver is high impact for Irish society and globally.
The vision of the project is that we want to, for the first time, take a food-derived peptide and put it into an oral dosage form that is suitable for pharmaceutical formulation. So the idea, what we're doing is we're marrying in a way food-derived technologies with technologies for the pharmaceutical industry, and that's a real first. But drilling down into the deliverables of the project, I think if we took one or two of Nuritas's peptides and made them into an oral delivery system that actually achieved preclinical data in animal models that proved that we had a bioavailability of a certain amount, I think that would be a pretty remarkable achievement.